As you start in this course, you're going to find a lot of people use the words mathematics and numeracy. You need to have a very clear understanding of what the difference of these two words are. You're going to find some people are going to say they're exactly the same, and numeracy is just a new word for mathematics. You're going to find other people who say, well, numeracy is about number, because they get muddled up with the NUM in number and the NUM in numeracy. However, it's actually quite more substantial than that. We now know in mathematics that what happens is a lot of people can do their mathematics that they do at school, but they haven't been able to transfer it over to the world beyond schools. And so often when they're trying to make judgments about what's the best buy in the supermarket, or should I take this home loan out, or all of those sorts of things that we face in everyday life, they don't use the mathematics that they need to use. So what has happened now is we're taking a much stronger focus on numeracy. But to be numerate, you also have to know the mathematics. So it's not much point being numerate if you can't add or if you don't know what mathematics to apply, those sorts of things. So what we do now in mathematics is we have mathematics, which is about what we call the esoteric mathematics, the pure mathematics if you like, and numeracy, which is much more the applied. The Australian Association of Maths Teachers actually talk about having a disposition to use mathematics and mathematical ideas and mathematical processes to solve everyday problems. So what you're going to find in this course and your subsequent course is we're going to use these terms a lot. So in the informatics that you're just about to have a look at, what we can see are two different ideas. One is the numeracy idea and the other is the mathematics idea. You might remember when you were at school, you did Pythagoras, a squared plus b squared equals c squared. And that was how you'd find out the length of a side, because if you had a triangle that had a side that was three squares, which made a 9, and then the other side was 4 squares, which made 16, you'd have to find out the length of the hypotenuse, that long side that runs between those two angles. Now this only works, remember, for a right angled triangle. It doesn't work for all other triangles. So while you were at school, you probably had to play with a squared plus b squared equals c squared. And you never realised why you would need that other than to solve problems in school and out of your textbook. However, what we do know, and so that's mathematics, but what we do know is that if you work in the real world, in the world beyond school, builders need to know that if they're building something and they're building, say, a door frame or a window frame, they need to know that square. So they might have a square, an instrument, but they also know that they have this thing called a 3, 4, 5. And if they've got a 3, 4, 5 triangle, so one side's 3 units long, whatever that might be, the other is 4 units long, and so long as the hypotenuse is 5 units long, that corner where the 3 and the 4 meet is actually going to be very square. So many builders use that notion. So in actual fact, what they're doing is they're using Pythagoras that they learnt at school in everyday context and using it very, very successfully. But they won't call it Pythagoras, they'll just call it a 3, 4, 5. So this is the difference between numeracy and mathematics. Now another thing that we know is that when we teach subtraction, for example, one of the biggest problems we have in maths is when we have to subtract numbers and there's zeros, internal zeros. So if you give a problem like 5.00, subtract or take away or minus, whichever word you would like to use, 1.35, a lot of people will say, oh, I don't know how to do this, and they might start to panic. So we start to put it down in laying it out in the columns. So we have, on our first line, we have 5.00, then we put our subtraction sign, and then directly underneath all of those numbers, we go through a process where the 1 is directly below the 5 and the decimal points line up, and then the 3 and then the 5. Then we have to start taking them all away. And you probably remember that process. Now we know that kids get this wrong, they will take it all away incorrectly, and they have no real understanding of what they've got to do. Hopefully, if they do a check afterwards and they add the answer up with the 1.35, it'll add up to 5.00. However, there's a very strong disempowerment with that, but that's mathematics. So it's done in a very abstract way, and often people aren't really sure about what's going on. However, when we think about numeracy, if I say to you, Here's $5. Go and buy a Mars bar. Now we know the Mars bars are on special this week. It's $1.35. You can see the numbers are exactly the same. 5.00 is our $5 and 1.35 is $1.35. So what happens now? You think about how you would work that out. I bet almost with 100% certainty that you're probably not going to use the algorithm that we've taught you in school. You're probably going to use a strategy, something like, well, if I add 5 to it, that will make it up to 40 cents. Then I have to add another 60 cents. So that's 65 cents. So now I've got $2. So to find that out, I take away $3 from that. So it must be $3.65. And if you do that, you're probably very, very confident that you've got the right answer. So that's the difference between when we're talking about numeracy and mathematics. Often we need the mathematical ideas. We need to know what these things are that we do in mathematics. We need to have proficiency with number. We need to understand number, all of those things. But the numeracy part is applying it into contexts that make real sense for the learner. So hopefully now you've got a better idea of what the difference between numeracy and mathematics is.